So very happy to have a very new or very different topic compared to the ones that we had before. We talked a lot about asset pricing, asset management at the beginning, talked a bit about more like corporate finance topic, but this is, I think, the first one where we look a bit more into sort of macroeconomic use cases, so to speak, of artificial intelligence. And we have two excellent speakers who can actually do that. So as always, just to give a little bit of brief introduction because we hand over to Sophia and Miguel. So let me start. First of all, we started this webinar, as those of you already know who have been with us a couple of times, end of last year, together with Paulina, who is a PhD student here at Frankfurt School, and Birgit, who is founder of a Frankfurt-based consultant company who works specifically with our Center for European Transformation. And we started this or hosted this specifically at the center because artificial intelligence or advances in digital media, so to speak, is a huge and important way which sort of transforms a lot of things that we have to do with that we are dealing with on a day-to-day basis, so to speak. And we were coming from basically from on the one hand from an academic perspective, given that we also work on these AI topics and different use cases in finance, but then talking also to practitioners, we found that basically everybody is working more or less as relatively similar questions, but have relatively different approaches, but also similar problems in terms of, okay, there's some sort of like a black box in terms of how do we actually sort of have to think about what's actually going on here. So we thought, oh, it might be actually an interesting idea to do a webinar which incorporates both. Not only, as we usually know, there's an academic speaker and more or less an academic discussion, but bring an academic and a practitioner together and discuss one particular use case at the time, and then see sort of what can we learn from each other and what are maybe even better approaches in practice that we do in academia or the other way around. So I think this is a very interesting setup to do, and I think we have a lot of different use cases, and we're going to have also more coming up after the summer break that we can discuss. One thing that I should tell you is that this, as always, is a meeting that is going to be video recorded, and we're going to put all of that on YouTube eventually, which you can see if you go on our center website. You can find the link also to our YouTube website. As always, you can get involved, and what you would like to do is, if you have, and we encourage you to do that, to post questions to Sophia and Miguel, you do that via the Q&A function. So here you have the opportunity to ask questions. Everybody from us can see that, and you can also vote, basically give thumbs up if you think this is a relevant question to basically put them up into the Q&A and the Q&A box. And if you have a technical question, what you can do is you can also put this into the general chat that we can basically get on with this right away. So before we start, let me briefly introduce our two speakers. So we have Sophia Kazinnik, who is joining us from Palo Alto, from Stanford, where she's currently a senior researcher at an AI institute at Stanford, and she's going to present her paper simulating the survey of professional forecasters. And Sophia has a PhD from Houston and then has worked for some time in the Federal Reserve System, has worked also with lots of different use cases and AI also in terms of like stress testing, operational risk of banks, and then moved to Stanford about a year ago. And Miguel is also at the Federal Reserve System, but works on these topics from a very, very different perspective. He got a PhD from New York University, basically out in the same year as Sophia finished her PhD as well, and then started his work at the Federal Reserve Bank of St. Louis, where he's currently an economic advisor, and is publishing in all kinds of different top journals in finance and economics. So he's very well versed in these topics as well. So before I hand over to you guys, what I would like to do in order to get our participants involved, I would like to give you a short poll, as always, that relates to our session today and asks about what do you guys expect in terms of how we can use large language models in macroeconomic forecasting. So I'm going to start this poll now. And the question is, what is your expectation regarding the use of large language model in macroeconomic forecasting compared to human professional forecasters? So we have AI forecasters will consistently outperform the humans. AI forecasters will outperform humans only at longer horizons. AI and human forecasts will have similar accuracy, and AI forecasts will not outperform human professional forecasters. So give you a few seconds that everybody can express his or her opinion, and then let's see where we end up. So we have 60% already. We have a couple more coming in. 5 more seconds. 4, 3, 2, 1, and let's end this. And now let's look at this. So now everybody should see the results, I think. So who is first? So we have a tie basically. AI forecast outperforms at longer horizons or have similar accuracy, and 22% say it's consistently better, and 15% it will not outperform. So handing over to you, Sophia and Miguel, is this something you would have expected, or is this something that is sort of completely unexpected?
Well, Sasha, it's such a perfect poll for this seminar today. So this is interesting because it really depends on the variable and the horizon, and this is exactly what we show in the paper. So I'm not exactly surprised that there is such a distribution of answers. Don't know, Miguel, if you...
Yeah, I was going to say it seems that most of the audience has read or at least skimmed Sophia's paper, because it's going to be like, without wanting to spoil things, it's going to be like one of the main findings of the paper. Yeah, I think the things are it's still early to assess these, but I would say if I were to vote, I would have probably agreed with one of these two options.
Perfect. All right. So then we're off to a very good start. Let's end this now. And I hand over to you both. Thank you so much for being here. Sophia, fire away, floor is yours. Thank you.
Fantastic. Thank you so much. Thank you for the introduction and for the invitation. I'm really excited to be here today. Let me go into full screen, some slides. Okay, sharing. You can see them?
Yes, perfectly. Thank you.
Okay, perfect. Okay. All right. So let me jump right in. Today I'm presenting this paper called Simulating the Survey of Professional Forecasters. We are using large language models for this exercise. So let me just spend a slide trying to convince you that this is an appropriate method for this type of exercise. Well, we now have this large and growing body of literature showing that large language models can produce responses that are consistent with documented patterns of human behavior. This result has been replicated across different contexts and across different literatures. And this quality essentially stems both from this vast training data that LLMs ingest, as well as their model architecture. For example, if you were to read just one paper, I would strongly advise to read this paper by John Horton, where he replicates various famous behavioral econ experiments using large language models, showing that they align with the expected outcome. LLMs are also really good at role playing. They are able to align their behavior with different personality profiles, and they manage to exhibit personality consistency and so on. So all of this is just to say that LLMs are human enough. Human enough for what? Human enough to be useful in social science research, economics included. So this is what we're using them for in this setup. Specifically, we're replicating the SPF, Survey of Professional Forecasters. In general, survey-based forecasts are extremely important for policymakers, as well as practitioners and people in academia. But policymakers in particular, they need to know the situation on the ground, what people are thinking about the economy, and the direction in which it's headed. At the same time, survey data collection is costly. It has been more and more difficult to collect survey data.
Sophia, just 1 second. Maybe it's only me. I don't know whether you already switched slides, but I see still the initial slide.
Oh, really? No, I've switched slides.
Do you see that, everybody else?
Yeah, I still see the title slide.
The title slide, right? So maybe you need to go to.
What about now?
It's still the title slide.
Oh, what a shame. Let me try to share it again. Okay.
Now we are on slide 4. We're on the now motivation. Yeah.
Fantastic. Okay, so
perfect. Thank you.
So we were here most of the time. If anyone is interested in the literature mentioned, and now moving on to the slide. All right, so as I was saying, survey data collection is costly, especially if you're surveying experts, right? Their time is costly and so on. You can't really do it on a frequent basis. You can't really introduce new questions and so on. So if LLMs are really good at replicating human behavior, we could potentially use these tools to augment survey data collection by simulating agent behavior. So this could be in principle a game changer, at least for policymakers and central banks, right? Because it introduces this flexibility in terms of generating forecasts. And central banks are waking up to this. For example, the Czech National Bank has been experimenting with the use of AI in inflation forecasting, actually following the paper of my discussant today. And I'm sure this is, the first but not the last example of this. We'll be seeing central banks experimenting with these methods more and more. So as for this paper, let me talk first a little bit about how we think about human versus AI forecasting, to describe a mathematical framework that we use to think about it, and then I'll talk a little bit about the simulation and the results as well. So our framework here, let's say that the forecasting process can be described as a function of two inputs, a set of observable predictors X and a set of unobservable predictors Z, plus some unpredictable error with zero mean. So unobservable set of predictors would represent any additional information that could help predict Y, but at the same time is very hard or nearly impossible to quantify. So things such as private insight, domain knowledge, intuition, internalized rules, something that's very difficult to capture and quantify. So humans obviously can access both X and Z, but we do so imperfectly, right? Because there are physical limits. We can't really process a huge amount of observable data, right? If you give me 2 variables, I would do okay in terms of decision making. If you give me 100 variables, the outcome will not be as good. We're also all are different, so we process information in different ways, right? We all have our biases. So the human prediction process has this term here that might not have zero mean due to different biases. Now, traditional algorithms cannot access that, but they're really good at processing X efficiently. So they're really good at this mapping of X to Y. And it doesn't really matter if you give them 2 variables or 100 variables, they will perform the task really well. LLMs are similar to traditional algorithms in that they cannot access that, but their expectations are formed differently, right? They haven't been trained by this direct mapping of X to Y, but they have been trained on this massive text-based data, essentially the sum of everything that we as humanity have ever written. So they learned over this massive text-based probability distribution. Now, if we want to use LLMs to mimic the human forecasting process, we need to minimize the distance between the human bias and LLM bias. So what do we do? How do we do this in this paper? We are essentially giving them, the LLM, 2 pieces of additional information beyond the observable data. So we're giving them forecaster characteristics to capture systematic patterns in biases, this term here. And we're also feeding it past median SPF forecasts to proxy for unobservable Z, right? So the past median SPF forecasts are the forecasts that were made by humans, which, during the decision-making process, they have incorporated both X and Z, both observable and unobservable information, so their decision-making output contains that part of Z. So this helps LLMs mimic humans in their forecasting process, and this is essentially our setup here. It describes all of the inputs that we're giving to the LLM. So I know this is a little bit abstract, and I will show you exactly how the simulation looks in practice. Very quickly, a couple of words on the SPF. So Survey of Professional Forecasters, one of the oldest surveys of macroeconomic expectations in the US. It also has a European counterpart. This is a kind of a survey that attracts a lot of attention. It's highly watched. It's widely used by policymakers and economic researchers. It's large. It produces point forecasts for 23 variables across 9 horizons. Survey responses are released at the individual level, but without forecaster identifiers. So forecasters are essentially anonymous. At the same time, the published surveys include names and affiliations of recent participants. So we're able to grab the names and affiliations, as well as the actual survey time, and use this information to build our forecaster personas. And we are essentially reproducing the whole panel. We're focusing on 5 horizons, nowcast plus 1 to 4 quarters ahead. This is our sample from 1999 to 2023, and we're using 2024 data for out-of-sample validation. Because the models that we've been using had a knowledge cutoff up to 2023. So, all right, let me talk a little bit about the actual simulation here. We start by collecting data in order to build our synthetic forecaster personas. So we start by gathering names and affiliations, and then we use publicly available data such as LinkedIn, web search, personal websites, and so on to gather a set of characteristics for our synthetic forecasters. So things like education, job title, current affiliation, where the company is located, whether the forecasters give interviews or engage with the media, where they were born, and so on. I'm skipping this in the interest of time, but it was actually pretty interesting to see who participates in the SPF, and these features vary widely, both over time and across SPF participants. So if you're interested, this data is in the paper. So we gather those personal characteristics, and we essentially feed these characteristics into our set of LLMs. So we're using all of the OpenAI models, not all of them, but I think 3 or 4 that were state of the art at the time of the simulation. And we are also using DeepSeek and Llama models for this. So we prompt these models with our personas, and we also feed in the real-time data and the past SPF median forecasts, essentially, following this setup right here. And then the model is then instructed to forecast the same variables over the same horizons as human SPF forecasters. So the idea is to reproduce the informational environment as close as possible with respect to actual human forecasters. So when we run the simulation, we get the output from the model, and then we compare that output to actual SPF predictions and realized outcomes. So again, this is pretty abstract. Let me show you the actual simulation setup. So this is the prompt, kind of the heart, the engine of the whole simulation. This is what is driving this. So in the red here, you see the variable inputs. So we run the simulation over and over in a loop while we vary the inputs. I know this is a lot, so let me just break it down into pieces here. So we start by defining the persona. We are essentially saying you are a participant on a panel of survey of professional forecasters. Your name is tada, you graduated from this institution with this education around this year, and so on. If a piece of information is missing, we're simply not including a sentence related to that piece of information. So next, we introduce our first temporal restriction. We are telling the model, we are in, let's say, Q2 of 2019. You are about to fill out the forecast form for Q2 2019, using only the information available to you as of Q2 2019. Provide your best numeric forecasts for the following variables. We then sort of define the horizon and feed it the most recent real-time data as of Q2 2019, and as well as the past median forecasts. Then we introduce another temporal restriction saying do not incorporate any data that was not available to you beyond the current date. Consider all relevant information and so on. And then some additional instructions saying that, use your professional judgment, provide a forecast in the following format, and so on. So this is sort of the whole thing. Okay. Now let's look at the results. So this is a large simulation. We have a lot of variables, 20 plus variables over 5 horizons for 2 different sets of forecasters, human and AI forecasters. So it's rather difficult to show everything. The full set of results is in the paper, so I'll just focus on a couple of variables. But again, if you're interested in the details, it's in the paper. So what do we find? And this is going back to the poll, the results of the poll we just saw. So there are 3 main takeaways in this paper. So first, we see that AI and human forecaster predictions are qualitatively similar. So they are predicting these variables in a similar way, but there are quantitative differences. With respect to those differences, AI forecasters often achieve lower forecasting errors. This doesn't hold for all variables and all horizons, but on average, AI forecasters are more accurate. But this accuracy hinges on us giving AI forecasters human inputs. right? The personal characteristics and the past median forecasts made by actual humans. If we remove this human input from the simulation, the accuracy deteriorates. So ultimately, this is a framework of augmentation, not substitution, at least at this point in time. So let's look closely into each of the takeaways. And do I have a few minutes still? Sorry.
Sure, go ahead. Sure, go ahead.
Yeah. Okay. So how do AI and human forecasters compare? So this is a large table. I'm not going to go over everything, but it's essentially showing the forecast accuracy as measured by mean average error for AI and human forecasters across 3 horizons: nowcast, 1 quarter ahead, and 4 quarters ahead. And these are the variables that we have. So the bold-faced values are the lowest mean average error for that variable and horizon and forecaster. So you can see that there are no clear winners necessarily. AI is often more accurate, but there are still instances where human forecasters are more accurate. So, and there's quite a bit of difference across variables. Let's look at a couple of those variables in more detail. So here we have median forecasts over time for CPI inflation. So the dark gray line is AI forecasters. The light gray line is human forecasters, and the shaded areas are NBR recessions. So you can see that although the forecasts are moving together, AI forecasters are definitely overreacting around the turning points, right? And their forecasts kind of are more sharp. There is higher variance here. And this is interesting. We think that one of the reasons this is happening is because for variables such as CPI inflation, it helps to have access to this Z component, right? The unobservable component, and being able to incorporate it, especially in short-term horizons. There's also a lot of kind of narrative, negative narrative about turning points in the training data, I would presume. So our AI forecasters might be overreacting due to that. Then if you look at another variable such as T-bill rate, you can see that there's way less divergence here. So the forecasts are moving very closely. What is interesting here is how AI is predicting, is forecasting, T-bill rate around the 0 lower bound period as opposed to humans. So humans are predicting this liftoff consistently, while AI forecasters kind of are more mechanical in this respect. And finally, let's look at real GDP. So you see here that these are essentially, identical. They move closely together. So real GDP is not as doesn't have such high variance such as CPI inflation. So there isn't much variability here. Okay, so let's look at accuracy. I've shown you the table. You can see that AI forecasts often outperform human forecasts, especially at longer horizons. There's some heterogeneity across variables, so it's really good at forecasting variables such as real GDP and unemployment rate, but not as good at forecasting things such as CPI inflation, for example. And including past SPF data is essential for strong performance, and I will show you a table that kind of drives that point home. So we think that this accuracy actually stems from the fact that we give LLMs this latent information, Z, by including past SPF forecasts. But at the same time, an LLM is this powerful deep neural network model, so it's also very good at processing X more effectively than humans. So it has an edge in that sense. And this is just showing the proportion of quarters where AI is more accurate. So again, it often beats humans, more often than not, but not for every variable. All right, so let's talk about the value of human input. We're giving the model several elements that are supposed to help it simulate human behavior as close as possible. So we are interested to see which of those elements are driving the boost in the performance. So in this table here, we have 3 columns where we remove those human inputs one by one and look at how the accuracy of their predictions changes. So here in this first column, we are just taking away the personas that we built, right? So this is just a generic forecaster persona, but it receives the same real-time data and past SPF forecasts as previously. And the numbers here are just the values, mean average errors of this simulation relative to the mean average error of the baseline simulation, right, with forecaster personas. So you can see that there's definitely some, not a dramatic amount, but there is some extra accuracy that personas bring into the simulation. Next, we remove both the persona and the real-time data, right? And you can see that the accuracy in most cases deteriorates even more when we remove the access to real-time data. But what really seems to matter a lot is the inclusion of past SPF forecasts into the simulation. So when we remove all 3 elements, the accuracy deteriorates considerably. Right.
Sophia, just very quickly, is it possible to wrap up in 2 minutes or so that we have enough time for the discussion afterwards?
Absolutely. So
there are lots of Q&As already coming in. I think it might be interesting.
Fantastic, Sasha. Yes, I apologize. So just this one slide, and I'm wrapping up. So simply because this point comes up a lot. So the argument goes like this: what if LLMs are just recalling future data from its training set, right? Because it's trained on the whole universe of the data, right? So we are applying a couple of mitigation techniques, right? When we do the temporal restriction and feeding it real-time data, and we also do this out-of-sample test. But to really get comfortable with this, we conduct a so-called recall test. We essentially ask the model to recall past realized values from the data set and compare it to the actual forecasting exercise. So on average, we see that the errors in this case are about 16 times larger than our baseline nowcasting results. So this gives us some comfort here. To wrap up, humans have access to observable insights, but can suffer from systematic biases. LLMs, on the other hand, see only structured data and historical patterns, but are able to approximate those latent aspects by ingesting additional human inputs. So ultimately, hybrid approach seems to be the way to go. We show that AI plus human signals can exceed pure human or purely data-driven forecasts. So this is a potentially powerful tool for policy or research, something along the lines of a virtual forecasting lab. So I'm going to stop here. Sorry if I went a little over time.
No problem. I think this is an interesting topic. So Miguel, I hand over directly to you. Thank you, Sophia. And maybe, Miguel, you can already incorporate some of the chat Q&A questions go in a similar direction, I think, compared to what also Sophia just talked about.
Yes, actually, yeah. So I noticed some of the Q&A that's going to be like one of my main comments in the presentation is going to be related to the same question that keeps popping up in the Q&A. And I'm going to talk a little bit about it and how I think these can potentially be addressed. So yeah, first of all, before I start, let me just say that these are all my own views and are not the views of the St. Louis Fed or the Federal Reserve System. So I'm just going to do very briefly, very quickly, I'm just going to summarize what Sophia just described. Basically, the main question is, can we use LLMs to simulate surveys? So in particular, the survey of professional forecasters, which is one of the most important surveys for people who track macroeconomic and financial aggregates. Human forecasters, typically, they're going to produce a forecast that's a function of some observed XT and unobserved ZT inputs. Think about like current data that's available, as well as like things that we don't actually observe, but people put into how they cook their forecasts, plus some individual term that the authors call a personal bias. And they use this very simple framework to argue that to establish that the forecast that would come out of an LLM is going to be the expectation, an expectation operator that's going to depend on the specific model that has been trained on some training data of the systematic component of the forecast. And what the authors are going to focus on this paper is what is this expectation that's generated by the LLM of the systematic component once we condition these expectation on observed inputs, past forecasts, as well as personal characteristics of the forecasters. And the idea is that these two last conditioning elements are going to hopefully help in accounting for this personal bias element. And basically what the authors do is they collect a lot of everyone should definitely read the paper. It's a fantastic primer on how the SPF works and actually who is part of the SPF. I use the SPF a lot in both my policy work and my research work. And I did learn quite a bit from reading the paper. So the authors collect a lot of detailed data on SPF member characteristics, these variable that they term WIT, and then they basically come up with this prompt that allows them to compute this expectation term, and where they condition on things like past SPF forecast, that would be the HIT -1, currently observable data, that's what they call the real-time data, that would be part of these vector XT, as well as the SPF participants' personal characteristics. And this is an example of the prompt. Sophia went over this, so I'm not going to waste time, but they have a very detailed prompt that they feed to the LLM to try to elicit a forecast, a good approximation of what would be the forecast of that person that graduated from that university, works at that particular investment bank, and has certain demographic characteristics in a given situation where other variables take certain values, etc. So, and just a brief summary of what they find that qualitatively, in terms of central moments, averages, etc., human and LLM forecasts seem to be similar. There are some interesting differences. I don't want to make this too technical, but there are some interesting differences in terms of higher moments, in terms of the variances and skewness, etc., of the distributions that they obtain from simulating the SPF versus the distributions of forecasts that you see from the actual SPF. And they find that AI forecasts tend to outperform human forecasts, especially at longer horizons, which again is very consistent with actually the priors of the participants based on the poll that Sasha ran in the beginning. And these actually is similar to what I find in a paper with Fernando Lebovici from last year, where we basically ask one particular LLM, Google Palm, to forecast inflation over different horizons, and then compare that to central moments of SPF forecasts. And we find that especially at longer horizons, the LLM tends to outperform the SPF participants. Sophia mentioned these, and this is an important part of their paper, and I think it is actually one of the most interesting parts of their paper, is that conditioning on these personal characteristics of the SPF participants is extremely important to improve AI forecast accuracy. And this is where, like, I think Sophia expertly said that we shouldn't... Sophia's and their co-authors' results do not point to LLMs being a substitute for the SPF, but rather a way of kind of augmenting the SPF, because these individual characteristics seem to play an important role in driving some of these results. And And then this last point is basically the last slide that Sophia presented, that conditioning on current information matters for AI forecast accuracy. So it's the recall test that she described, that it seems some testing seems to indicate that the LLM is not simply using after the fact information that was not available at the time of the forecast. I have two main comments. I'm going to skip the first comment and I'll just send the slides to Sophia later, because the first comment is a bit more technical and it's probably boring for most people in the audience. So I'm going to focus on the second comment, which is very much in line with a lot of the questions that came up in the Q&A, which is basically there's no way of guaranteeing that the AI forecasts are truly out of sample, which raises the question of whether this is a fair comparison or not. So let me skip the first comment, and this is the second comment, which I'm going to be very quick here, because it seems that based on the questions that people are asking, a lot of people thought about these as well. And this is a problem that we also had in our paper, is that at the end of the day, the researcher who's using the LLM for a given purpose, we have almost no control over the training data set for the LLM. So the LLM is trained with a lot of data that's completely out of our control. That goes from some time 1 to capital T. Which means that this expectation function, the ETAI, is going to be a function of all this training data up to this capital time T. And this capital time T might be a date that's after the date for which we're asking for the forecasts. And this is just a very brief example, like making things a bit less abstract. If you have a model that has been trained using data that goes from 2017 to 2024, we'll be asking the model to conducting forecasts in January 2022. So in the middle of the training data. So, and the problem with these is that obviously it means that these AI forecasts are not truly out of sample. So the comparison with respect to the truly out of sample SPF forecast is a little bit, quote unquote, unfair. Now, how do the authors address these? And this is also like what I did in my earlier work, is to add a conditioning sentence to the prompt. And we explicitly ask the LLM, please do not incorporate any data that was not available to you beyond the current date in your forecasts. And this is like just a screenshot of the prompt that Sophia and her co-authors introduce. Unfortunately, there is no way for us, the researchers who are using the LLM, to guarantee that the LLM will truly respect these. I believe that the authors understand that this is like an issue in the paper, and they do a lot of robustness with respect to these, which is very helpful, because, and this is the recall test that Sophia mentioned, that basically if we remove these and we just ask the LLM to recall what was a certain variable at this date, all of a sudden the LLM starts producing forecasts that are much more accurate, which suggests that the LLM is to some extent following part of this instruction to some extent. But still, as a researcher, as just a user of the LLM, there's no way to guarantee that the LLM is completely doing this. And it might even be that the LLM is trying to do these, but it cannot fully do, because at the end of the day, all of the parameters of the neural network that constitute the LLM have been estimated using the entire sample of data. So Sasha, I noticed that there's some raised hands. I don't know if we want to take some questions, or should I just finish this slide?
No, you can go ahead, and maybe if you see some comments that are consistent with what you said, you can incorporate those. Otherwise, we just bring them in after you're done.
Okay. So I'm almost done. So so I decided, based on the nature of this discussion, I decided to focus a little bit on what are the potential applications, especially for me as an economist at the Federal Reserve. So this is the best paper I've read on how to actually make LLMs useful for policy analysis. I feel that there's like an explosion of papers about these, but most of the papers are, I don't think they're very well thought out. This one is an exception. I think I really enjoyed reading the paper, and I think that conceptually, these approach has a lot of potential. Because as Sophia's motivated, human surveys are very expensive and they're very restrictive. They're expensive because you have to recruit all these very smart people who are chief economists and investment banks. These people have better things to do than to be filling out survey forms. And they're very restrictive because once we design a survey and we start running it, it becomes very costly to change. We don't want to be changing the survey all the time. Otherwise, the historical data for the surveys becomes kind of useless, right? So creating a toolbox that allows us to use AI to run surveys opens endless possibilities. So first, this is probably the most obvious one, it allows us to forecast other variables. So the SPF and the SPF participants are already asked about a series of macroeconomic variables, some of them extremely detailed, but we can like basically ask with an AI survey, we can ask about any variable, financial market variables, different components of consumption. What do you think is going to be the growth rate for automobile sales, airplane sales, all these things that are really that you wouldn't like bother putting in the main SPF, but could be of interest to policymakers along some dimension. You can forecast variables at higher frequencies. This is one of the main issues of the SPF. It's a quarterly survey. So for example, here at the Fed, we're worried about inflation every week, every month, but we only get, and we care about what the private sector forecasts are for inflation, but the SPF only comes out every quarter. If we have a reliable toolbox that generates AI forecast surveys, we could be trying to forecast inflation every day or every hour even, or forecasting variables at different horizons. What's going to be inflation next week? What's going to be inflation in 30 years from now? So this could be very useful and very important for policymakers. Now, what we need is to really make the comparison, is to ensure that the AI forecasters are not using out-of-sample data. And the crucial requirement from that, from a conceptual point of view, is we would need to have control over the data that we use to train our models. And in particular, we need to be able to timestamp the data to make sure that the model is not using data that's posterior to the data of the forecast. This would be like what I would love to have at the Fed. Unfortunately, training models, as anyone who has read a little bit about these models knows, is extremely expensive. And that's why, like, typically we only have these large companies, Meta, Google, etc. OpenAI training. It's the training of models is not widespread. It's starting to become a bit more widespread. There's a lot of technological progress in these, and some larger corporations are starting to have their own in-house trained models, but it's still costly, for example, for researchers to do it in a very straightforward manner. But I think that this is where this should go. If I understand that this is kind of like a bit tall or a big request, but this is where I would love to see this going. Is if leveraging latest advances in terms of computational power, etc. This is the end product that I would like to have at the Fed, is having a toolbox that allows me to control the data that goes into training the model to completely solve these in-sample issue. I think, but then again, I don't want people to think that I'm being too negative about these, as I'm going to repeat what I said before. This is the best paper that I've seen about using LLMs for something that's actually useful for policy. And I think that this is a conceptual problem, but the authors do a very good job in trying to convince the reader that these does not seem to be that much of an issue at the end of the day with all the tests that they run. And in particular, one of the tests that they run that I encourage them to keep doing is they know that the model was trained with data up to 23. And so they do like a real-time tests using 2024 data. Now, the problem with these becomes the opposite, is these could start becoming a bit unfair towards the AI because the AI is not being trained with the most current data. So here you get a little bit the reverse problem, but it's the right academic way of like trying to address this concern. And I'm going to shut up now and let discussion allow for the discussion to take place.
Awesome, perfect, Miguel. That was very clear. Specifically also the last part. I think the 2024 data are likely the most convincing part, at least for an academic towards these criticism. Sophia, maybe do you want to respond to Miguel, and then we open the floor for more questions?
Absolutely. I love your vision. And I mean, I do think that it should be possible for central banks to train their own models or a model, and they could make it chronologically consistent, right? Have timestamps, and this would be an immensely useful investment, right, going forward. So I know this is an aspirational kind of thing, but I'm with you, and fingers crossed it's going to happen. Thank you so much for the discussion. I absolutely agree with this point. we are kind of trying to get as comfortable as possible, right? In terms of this topic, we will continue updating our out of sample exercise as new data comes in. This is kind of the only thing that we can do currently. Asaf Manella and co-authors, they have this new working paper called Chronologically Consistent Large Language Models, where I think it's a bird-based model, where they kind of timestamp the data. So we might try to rerun the analysis using that. I'm not sure if they have an open source package, but I'll check. But yeah, I mean, I think that's the direction that this type of research will be going in the future.
Yeah.
Yeah, thank you.
Yeah. No. Yeah, you're welcome. It's like we had the same issue in our paper, and actually I started talking to a lot of machine learning people, etc. Here at Washington University. They have like a big engineering department. And the main constraint that we came across is that no one ever bothers timestamping the data that they use to train these models.
It's difficult.
Yeah. So yeah, it's I did not know about that Asaf Manel paper. I'll definitely check it out.
Yeah, so it's really good. Yeah, but yeah.
So I have actually a question that just popped into my head. So last week I was moderating a panel discussion with various industry guys, also from Google and the like, on different AI use cases in finance and capital markets, for that matter. And one question that popped up, or one issue that they all highlighted that they could never really deal with, which was sort of like a model bias, right? So that AI is trained on past data. In this case, there might be some kind of forecasting biases. They might be trained on these biases, and they just perpetuate that. Is that something which is sort of like a real concern? Is this something you can deal with, or would you have done if you have dealt with?
So there are some practical ways in which you could identify certain biases within large language models, but it has to be an open source model. So anything that comes from a vendor, such as, OpenAI, Anthropic, and so on, we can't really do anything about it. So I think it's a practical choice whether to use these models or not. If it's an open source model, you could kind of look under the hood a little bit more, and there are ways to, amplify or reduce certain biases. I'm sure it will become sort of a part of like model risk management package when it comes to LLMs going forward. But it's still early.
Yeah, that makes a lot of sense. So, but as you both said, and Miguel, you were very bullish on that front, so to speak, that there are basically like endless applications when it comes to that type of technology, right? So also when you think about beyond, so I'm not a macro guy. I'm usually think more about like the simple like corporate finance questions and the like, but also here we have these surveys. We have the IFO index in Germany, which always talks to like SMEs and tries to forecast what do they expect in terms of how things go moving forward, right? All these kind of things. Is this sort of something that could be complementing all of that? Are there kind of limits what these models can done? So where should we think, okay, this is sort of there's a limit where we cannot go beyond, so to speak.
So I can take it, and then Miguel, I'll pass it on to you as well. I don't want to. So Sasha, this is a great question. I think any scenario where you do have some type of ground truth is okay. When there are scenarios that you can't really benchmark to anything, then you're in trouble, because you don't want to become too untethered and just start simulating things that you cannot validate, and God knows what happens then. But yeah, if you can stay grounded and have validation data, then I think you're fine.
Yeah, so allow me to be even more bullish than I was before. I think that as long as it's something for which some data exists, then we can train it and we can put it as a left-hand side variable. And the beauty of deep learning is that, like, the way that economists and a lot of market practitioners typically do forecasting is just using econometric models, right? Think about a VAR, vector autoregression. There's a lot of discretion that goes into a VAR because I'm choosing which variables to put on the left-hand side and which variables to put on the right-hand side. I think that one of the nice things about these, and this is why I'm so bullish about this, is that this is like we have this very smart algorithm choosing which variables are going on the right-hand side. And these could be variables that wouldn't even like cross our minds. And obviously there's the danger of including spurious stuff, but typically for forecasting, we don't, as long as we're not worried about causality, which is typically what economists are very worried about, if we're just worried about forecasting, spuriousness is not that much of an issue. So, and what I have in mind is things, and this comes from actual policy discussions that we have here at the Fed, is at some point someone would love to have a higher frequency measure of markups. So the difference between the prices at which firms sell a product and their costs, an aggregate measure of that for the economy. So markups are extremely hard to measure because there's a lot of conceptual issues on measuring them, and the data tends to be at best quarterly. But sometimes we want to know, are firms like raising their prices for a given level of costs in response to some change in policy, etc. And it's hard to get high frequency data for that. I think these would be like a fantastic application for these type of models, because yeah, there's so many discussions on how to measure markups that are not yet settled. But if we just want to forecast them, this is a fantastic way of doing it, I think.
Perfect. So I think this gives a lot of hope for much more research in all types of areas or more interesting models. I think that's maybe just looking into the Q&A because we're almost out of time. So I think that Nikan had an interesting question. I don't know whether you have thought about this at some point. Since you are simulating using LLMs, we was curious to know if you have tried agent systems to simulate the department of forecasters with different jobs. Is this something you have thought about or something that's sort of like doable?
Well, I'm currently working on another application of this sort of agentic system related to FOMC, but this could be definitely something that we could try, right? Sort of have the forecaster in charge that sends tasks downstream and then have specialized forecasters kind of work on that. So it's definitely possible. But I mean, here the idea was to replicate the SPF as close as possible. But there are definitely ways to do this in a different way.
Perfect. Miguel, you have experience in that area too, or?
Not really. I did not think about that. I'm not super familiar with the agentic systems, but I know more or less what they are. So I don't really understand what are the pros and cons of doing that, but it sounds super interesting. Yeah.
Yeah. So a lot of things that will come out in the future. So we're looking forward to that. So I think we are almost out of time. So first of all, thank you both. That was a fantastic session. I actually learned a lot. I was always curious to see sort of how good these things are and whether they are useful or not. And now I have a much better idea about this. I just wanted to close. I'm going to share this. Hang on. Awesome. Now you should see this. Oops. So we're going into summer break, but it's not that we're completely not doing anything over the next couple of months until we're back in September. We also want to sort of revamp this whole webinar a little bit. So this is why we like to have some feedback, particularly if you've seen this today, maybe you've seen this a couple of times. You can scan the barcode here, or you can also just simply, I think also the link is also in the chat already. That you can give us some feedback, what you would like to see. It could be topics you would like to see. It could be moderation is completely bad, change that, something like that, that we have an idea sort of what's actually going on. And otherwise, thank you guys again for participating, for the question that you're posing. Sophia and Miguel, thanks so much for taking your time today. Hope to see you both in person at some point in the future again. And everybody else, have a good summer and see you guys back in September. Thank you.
Thank you.
Thank you.
Thank you so much.
Awesome. This was really perfect. So I'm really